Here, let's find the fifth term and the nth term of the geometric sequence whose initial term a and the common ratio r are given. Here, the initial term is radical 7. Common ratio is radical 7 as well. The initial term is the first term, is normally denoted by a sub 1. And then by the formula, the nth term should be equal to the first term times the ratio to the exponent. The exponent is 1 less than the sub-index n. So if here is n, here is always exponent is always 1 less than this sub-index. We have an initial term is radical 7, or you may say radical 7 to the first power. And the ratio is radical 7 as well to the n minus 1. Now we know here the exponent is 1, here is n minus 1. The bases are the same. They are all both radical 7. So when you do the multiplication, we should add 1 plus n minus 1. That's the operation on the exponents. 1 plus n minus 1, so you have only n left, because 1 negative 1, they cancel each other. Now the exponent is n. Radical 7 is actually 7 to the 1/2. 1/2 times n is n over 2. Now here we then get a first one is the nth term of the geometric sequence is actually 7 to the n over 2. Now we need the fifth term. The fifth term is when n equals 5. And then you substitute 5 for n. You have a 5 over 2. 5 over 2 is actually 2.5. And 2.5 is 2 plus 0.5. We know 0.5 is 1/2. So it's basically 7 plus 1/2. All right. 7 to the exponent, which is one number plus another, is basically 7 squared times 7 to the 1/2. Again, 0.5 is 1/2. 7 squared is 49. 7 to the 1/2 or to the 0.5. And we know 7 to the 1/2 is radical 7. So here the fifth term would be 49 times radical 7. And here we have found again the fifth term is the one here, 49 times radical 7. And the nth term is 7 to the n over 2. All right, see you next time.